3 Starship explosions. Ship 36 destroyed. Flight 9 disintegrated. Now Ship 37 must save Elon's $10 billion Mars dream. But here's the terrifying truth. One more failure could kill SpaceX's entire future. Why is Flight 10 so different? What makes this mission more critical than SpaceX even realizes? The answer will shock you. Let's dive right in. August 6th isn't just another launch date. It's Judgment Day for SpaceX's entire Mars program. While millions of eyes will be watching Ship 37 lift off from Starbase, what they won't see is the desperation behind the scenes. 3 consecutive explosions have pushed SpaceX to the brink of a crisis that could kill Elon Musk's $10 billion dream forever. But here's what nobody's talking about. The real reason this flight is so dangerous isn't what you think. Let me paint you a picture of devastation. Flight 7, a massive fireball in the engine section, turned a $500 million rocket into space junk. Flight 8, another engine fire, another total loss. Flight 9, the rocket disintegrated during re-entry like a shooting star burning up in the atmosphere. But the worst was yet to come. June 18th, 2025, Ship 36, the rocket originally built for Flight 10, exploded during what should have been a routine pressure test. Not during launch, not during landing, during a simple ground test. The culprit? A nitrogen pressurization system called COPV, a component so basic that a high school engineering student could understand it. Yet it destroyed hundreds of millions of dollars in rocket hardware in seconds. Think about that for a moment. If something so simple can fail so catastrophically, what does that say about the rest of the rocket? Here's where this story gets terrifying. SpaceX's valuation sits at $200 billion, built almost entirely on the promise that Starship will work. But what if it doesn't? Every failure chips away at investor confidence. Every explosion makes potential customers nervous. Every delay gives competitors like Blue Origin and NASA's SLS program more time to catch up. The brutal math is simple. SpaceX has approval for 25 launches this year. They've completed 6. Missing the August window pushes everything back, compressing the remaining flight schedule into an impossible timeline. But here's the twist. This isn't just about launch schedules. It's about something far more valuable. Deep inside SpaceX's internal documents lies a revenue projection that will blow your mind. Starlink isn't just aiming for $10 billion in annual revenue. They're targeting $50 billion by 2030. That's Netflix, Disney, and Amazon Prime combined. But here's the catch. It all depends on Starship. Right now, Falcon 9 can carry 21 to 29 Starlink satellites per mission. That's baby steps. Starship can deploy 400 satellites in a single launch, a 15x performance boost that would transform SpaceX from a rocket company into a telecommunications empire. The numbers are staggering. At current Falcon 9 rates, deploying 40,000 satellites would take 1,500 launches and cost $30 billion. Starship could do it in 100 launches for under $1 billion. But what if Flight 10 fails? What if Ship 37 explodes like its predecessors? The entire business model collapses. Investors flee. The Mars dream dies. While everyone focuses on Ship 37, the real danger might be lurking in Booster 16. This massive rocket stage has one job: land back on the launch tower using mechanical arms called chopsticks. Sounds crazy? It is. Remember Flight 9? The previous booster exploded during its landing burn just 6 minutes after liftoff. The cause? SpaceX was testing new aerodynamic profiles that disrupted fuel flow to the engines. When the Raptor engines couldn't reignite, 200 tons of metal and fuel became a guided missile heading for the Gulf of Mexico. Now they're trying the same maneuver with Booster 16, but this time they've redesigned the fuel lines and flight profiles. It's a massive gamble. If it works, it proves rapid reusability is possible. If it fails, it exposes a fundamental flaw in the entire Super Heavy design. Here's what makes this truly terrifying. Mars missions will require hundreds of these boosters launching in rapid succession. One failure, one explosion, one moment of bad luck, and the entire launch sequence stops. There's a disturbing pattern in SpaceX's history that nobody wants to talk about. Back in 2008, Falcon 1 failed 3 consecutive times. The company was weeks away from bankruptcy. Elon Musk was borrowing money from friends just to pay rent. Sound familiar? 3 Starship failures, mounting pressure, everything riding on the next flight. Falcon 1 Flight 4 succeeded, saving the company. But here's the crucial difference. In 2008, SpaceX was fighting for survival. In 2025, they're fighting for the future of human space exploration. The stakes aren't just higher, they're existential. A failure doesn't just hurt SpaceX's bottom line, it delays humanity's expansion to Mars by potentially decades. Ship 37 isn't just another test vehicle. It's the final judgment on whether Starship Block 2 is fundamentally flawed or genuinely revolutionary. Every lesson learned from 3 explosions is built into this rocket. The cryogenic pressure tests, passed. The static fire preparations, ongoing. The heat shield upgrades, installed. But here's the brutal truth about space exploration. You can fix 1,000 problems and still fail because of the one you didn't see coming. Re-entry remains Starship's biggest weakness. The belly flop maneuver that makes landing possible also makes the vehicle vulnerable to the same fate that destroyed Flight 9. One overheated tile, one wrong angle, one moment of lost control, and $500 million worth of cutting-edge technology becomes an expensive firework display. Here's something SpaceX doesn't want you to know. The Pentagon is watching Flight 10 with extreme interest. Why? Because Starship's capabilities extend far beyond civilian space exploration. The same rocket that could carry colonists to Mars could also deploy entire military satellite constellations in a single launch. The same system that promises cheap access to space could revolutionize global logistics, moving equipment and personnel anywhere on Earth in under an hour. Military contracts worth tens of billions hang in the balance. But these deals come with one non-negotiable requirement. The technology must work flawlessly. Government agencies don't tolerate failure like private investors do. A Flight 10 explosion doesn't just cost SpaceX commercial contracts. It hands the entire military space market to competitors like Blue Origin and United Launch Alliance. There's another reason Flight 10 is so critical, and it has nothing to do with Mars. China is aggressively pursuing its own reusable rocket program. Their Long March 10 rocket is designed to compete directly with Starship, and they're not slowing down. Every SpaceX failure gives China's space program more time to catch up. Every delayed launch allows Chinese engineers to study SpaceX's mistakes and avoid them. Every explosion proves that American space supremacy isn't guaranteed. The space race isn't just about scientific achievement anymore. It's about national security, economic dominance, and technological leadership for the next century. Let me explain why Flight 10 is so technically challenging that most engineers consider it impossible. Ship 37 must survive temperatures of 2,000 degrees Fahrenheit during re-entry, hot enough to melt copper. It must execute a controlled belly flop maneuver while traveling at 1,000 miles per hour. It must reignite its engines in the middle of this chaos and land precisely in the ocean. Meanwhile, Booster 16 must separate from the ship, flip around, fly back to the launch site, and land on a tower using mechanical arms, all while carrying enough fuel to potentially level several city blocks if something goes wrong. The margin for error is essentially zero. A single sensor malfunction, a single engine failure, a single moment of computer confusion, and the entire mission fails spectacularly. But SpaceX has a secret weapon that might save Flight 10, something called Raptor 3 engines. These aren't just improved versions of previous engines. They're fundamentally different machines. Where Raptor 2 engines look like a flying spaghetti monster with cables and components everywhere, Raptor 3 engines are sleek, simplified, and integrated. They produce 30% more thrust while weighing 200 pounds less. Most importantly, they're designed to work in the extreme conditions that destroyed previous flights. Advanced cooling systems, integrated components, and simplified designs reduce failure points from hundreds to dozens. But here's the catch. Ship 37 isn't equipped with Raptor 3 engines yet. It's still using the older, more failure-prone Raptor 2 design. The revolutionary new engines won't debut until Flight 8 or 9. Here's why August 6th is so crucial. It's not just a launch date, it's a deadline. SpaceX has committed to 25 launches this year, but they're already behind schedule. Missing the August window creates a domino effect that could push major missions into 2026. The Artemis program depends on Starship for moon landings. Commercial satellite customers have contracts worth billions. NASA's Mars sample return mission needs Starship's massive payload capacity. Every delay costs SpaceX millions in lost revenue and gives competitors time to develop their own solutions. The space industry doesn't wait for anyone, no matter how innovative or ambitious. As Ship 37 sits on the launch pad, fueled and ready, one question haunts every engineer at SpaceX. Have they learned enough from their failures? The nitrogen pressurization system has been redesigned. The engine bay fire suppression has been upgraded. The heat shield has been strengthened. The flight computer has been updated. But space exploration is unforgiving. The smallest oversight, the tiniest miscalculation, the briefest moment of bad luck can turn triumph into tragedy. Flight 10 isn't just about proving Starship works. It's about proving that human ingenuity can overcome any obstacle, that failure is just another step toward success, and that the dream of becoming a multiplanetary species is worth the risk. But what if they're wrong? What if some problems can't be solved? What if the Mars dream is just too ambitious for current technology? The countdown has begun. In hours, not days, we'll know if Elon Musk's vision survives or joins the graveyard of broken space dreams. So here we are, 3 failures behind us, 1 critical flight ahead. Ship 37 holds the key to humanity's greatest adventure, or its most expensive mistake. But here's what I keep thinking about. Maybe failure isn't the enemy. Maybe it's the price of attempting something impossible. Every explosion teaches us something. Every setback brings us closer to Mars. The real question isn't whether Flight 10 will succeed, it's whether we're brave enough to keep trying when the stakes are this high. What do you think? Are we pushing too hard, too fast? Or is this exactly what human progress looks like? Messy, dangerous, and absolutely necessary? Drop your thoughts below, and if you're as obsessed with humanity's space future as I am, hit that subscribe button. Because whether Flight 10 succeeds or fails, the story of our journey to the stars is just beginning. See you in the next one, Space Explorers. SpaceX's Dragon just did something that makes NASA's legendary shuttle look ancient. 19 days in space versus 18 days maximum. But that's not the crazy part. Dragon can stay docked for 210 days. That's 15 times longer than shuttle ever could. But how did private spacecraft technology just completely demolish what was once humanity's crown jewel? And why did SpaceX even do it? Let's dive right in. June 25th, 2025. SpaceX's Dragon capsule launched with Axiom Mission 4, but what happened 18 days later changed everything we thought we knew about spacecraft engineering. For decades, NASA's space shuttle dominated human spaceflight. 18 days maximum mission time. That wasn't just a guideline, it was a hard deadline written in physics. Cross that line, and astronauts would literally run out of air to breathe. Why? The shuttle was designed like a camping trip. Oxygen tanks, food packages, water containers, lithium hydroxide cartridges for CO2 removal. Everything crammed into every available corner. When supplies ran out, the mission was over. Period. But on July 14th, 2025, something unprecedented happened. Dragon hit day 19 and kept going. The question burning through NASA's corridors wasn't just how, it was, why didn't we think of this? Here's what makes Dragon's survival possible. ECLSS, Environmental Control and Life Support System. But this isn't your grandfather's life support system. Think of the shuttle's approach like a gas tank. Once empty, you're stranded. Dragon's ECLSS works like a recycling plant that never stops producing. The magic happens through constant automation. Dragon's sensors monitor oxygen and nitrogen levels every second, automatically adjusting the perfect mix. Carbon dioxide builds up. The system doesn't just filter it, It processes and recycles it. Temperature fluctuates, humidity changes, all controlled without human input. But here's the breakthrough that left NASA engineers speechless. Redundancy without bulk. The shuttle needed backup systems for backup systems, each adding weight and complexity. Dragon builds intelligence into every component, turning potential failures into self-correcting events. Those lithium hydroxide cartridges that crippled the shuttle? Dragon carries just enough for 10 days, designed to be swapped as needed. No waste, pure efficiency. And the result? Dragon can stay docked at the ISS for 210 days. That's not a typo. 7 months, 15 times longer than the shuttle ever dreamed possible. Let's break down what this really means. The shuttle's life support system was essentially a countdown timer to catastrophe. 18 days meant 432 hours of survival, then death. Dragon? While docked, it becomes a parasitic organism, feeding off the ISS's life support while conserving its own resources. But here's the genius move. It can power down sections of its life support to reduce strain, then instantly wake up as a fully functional lifeboat if needed. This isn't just impressive engineering, it's revolutionary thinking that makes NASA's approach look ancient. The shuttle was built like a sprint runner, designed for short bursts. Dragon is built like an ultramarathon champion, engineered for the long haul. Why does this matter? Because every day in space costs millions. The shuttle's 18-day limit meant paying launch costs for severely restricted research time. Dragon's 210-day capability changes the entire economic equation. But Axiom Mission 4 wasn't just about staying up longer. This crew conducted over 60 scientific experiments, the most ever on a private mission. Biomedical science, agriculture, advanced materials, neuroscience, space technology, fields that could reshape life on Earth. And here's what makes this even more shocking. Scientists from 31 countries contributed to this mission. 31 nations working together on a private spacecraft that just demolished everything NASA built. The crew itself made history. Shubhanshu Shukla from India,